Trends in the periodic table. I will teach you all the important trends in the periodic table with easy examples. First of all, let me teach you that what is meant by periodic trends. Well, consider this periodic table. We know that columns in the periodic table are called groups and rows in the periodic table are called periods. Now, as you move down the group or across the period, the elements change in certain ways. For example, in the 7th group, chlorine has smaller size than iodine. This difference in size of chlorine and iodine is called periodic trend. Thus, we define periodic trends as the elements change in certain ways as you move across the period or down the group. This change is called periodic trends. Let me repeat it. The elements change in certain ways as you move across the period or down the group. This change is called periodic trends. Remember that there are 4 important trends in the periodic table, like atomic radius, electronegativity, electron affinity, and ionization energy. Hence, note down these 4 important trends. Now we will learn the trends of atomic radius. We define atomic radius as the total distance from the nucleus of an atom to the outermost electron is called atomic radius. For example, consider this atom. The distance from the nucleus to the outermost electron is known as atomic radius. Hence, atomic radius is nothing but the size of an atom. Now we will learn the trends of atomic radius across the periods. Remember that atomic radius decreases across the period. I mean, when you move from the left to the right in periodic table, atomic radius decreases. It is because the number of protons increases. We know that electrons have negative charge and protons have positive charge. More protons means more positive charge. Hence, more positive charge or more protons pull the electrons towards the nucleus and atomic radius or atomic size decreases. Thus, we say that atomic size decreases across the period from left to the right. For example, in the 2nd period of periodic table, lithium has larger size and fluorine has smaller size. It is because from left to right, number of proton increases and outermost electrons experience more attractive force. As a result of this, size of atom decreases. Similarly, in 3rd period, sodium has larger atomic size and chlorine has smaller atomic size. Thus, we say that atomic radius decreases from left to right. Now we will learn atomic radius down the group. Remember that atomic radius increases down the group. It is because new electron shells are added. As a result of this, the size of atom increases. Now consider the 1st group of the periodic table. Here, lithium has smaller size than sodium. It is because lithium has 2 electron shells while sodium has 3 electron shells. Now in the 2nd group, magnesium has smaller size than calcium. It is because magnesium has smaller number of electron shells while calcium has larger number of electron shells. Therefore, we say that atomic radius decreases across the period and atomic radius increases down the group. Hence, note it down. Now we will learn the periodic trends of electronegativity. By electronegativity, I mean the ability of an atom to attract shear pair of electrons towards itself in a covalent bond. For example, consider these 2 atoms A and B. Let they both mutually share 1 pair of electrons to form a covalent bond. Let A atom pull this pair of electrons more towards itself, while B atom pulls the shear pair of electrons less towards itself. So we say that A atom is more electronegative because it strongly pulls the shear pair of electrons, while B atom is less electronegative because it weakly pulls the shear pair of electrons. Now we will learn trends of electronegativity in the period. Remember that electronegativity increases from the left to the right. It is because number of proton increases and the size of atoms decreases, due to which atom strongly pulls the shear pair of electrons. For example, in the 3rd period, chlorine is more electronegative than sodium. It is because chlorine has smaller size and sodium has larger size. While in the 2nd period, fluorine is highly electronegative than lithium because fluorine has smaller size and it easily pulls shear pair of electrons, while lithium has larger size and it cannot pull shear pair of electrons. Therefore, we say that electronegativity increases from left to right across the period. Now we will learn electronegativity down the group. Remember that down the group, electronegativity decreases. It is because more electron shells are added and size of atom increases, due to which atom has less ability to pull shear pair of electrons, or it weakly pulls shear pair of electrons. For example, in group 7, fluorine is highly electronegative than iodine. It is because fluorine has smaller size than iodine. Similarly, in group 6, oxygen is more electronegative than sulfur. It is because oxygen has smaller size and sulfur has larger size. Therefore, we say that electronegativity decreases down the group and it increases across the period. Hence, note it down. Now we will learn the trends of ionization energy and the periodic table. We define ionization energy as the energy required to remove outermost electron from an atom is called ionization energy. For example, consider sodium and chlorine. It is very easy to remove an electron from sodium. So sodium has smaller ionization energy. On the other hand, it is very difficult to remove an electron from the chlorine. So chlorine has higher ionization energy. Now we will learn ionization energy across the period from left to the right. In the periodic table, ionization energy increases from left to right. It is because atomic size decreases from left to right, due to which it is very difficult to remove an electron from outermost shell of an atom. For example, in the second period, boron has lower ionization energy than fluorine. It is because fluorine has smaller size than boron. On the other hand, in the third period, aluminium has a lower ionization energy than chlorine because chlorine has smaller size than aluminium. Hence, we say that chlorine has high ionization energy and aluminium has lower ionization energy. Thus, remember that ionization energy decreases from left to right in the period. Now we will learn trends of ionization energy down the group. Remember that ionization energy decreases as you go down the group from top to the bottom. It is because atoms are larger at the top and the attraction between nucleus and outermost electron is weak. Hence, atoms can easily lose electrons. For example, in first group, potassium has much lower ionization energy than lithium. It is because potassium is larger in size and its outer electron is farther from the nucleus. Hence, it can easily lose electron. On the other hand, barium has a much ionization energy than magnesium. Therefore, we say that ionization energy increases from left to right across the period, but it decreases down the group. Now we will learn periodic trends of electron affinity. Electron affinity means loving electron. We define electron affinity as the amount of energy released or absorbed when gaseous atom gains an electron to form a negatively charged ion is called electron affinity. Here, remember this very important point. We know that metals do not want to gain electron. That's why metals like sodium, magnesium, calcium lose electrons, while non-metals love to gain electrons. That's why non-metals like chlorine and oxygen always gains electrons. Here, consider this fluorine atom. Let we are interested to inject this electron to chlorine. Here, we don't need to provide some sort of energy to chlorine. Rather, when chlorine gains this electron, it will release energy in the surrounding. This negative sign means that it is an exothermic process because chlorine releases this energy after gaining an electron. Now we will learn trends of electron affinity across the period from left to right. Electron affinity becomes more negative or increases from left to right as you move across the period. It is because atoms want to accept an electron easily in order to complete their outermost shell. For example, in the second period, chlorine has high electron affinity than sodium. chlorine is non-metal and it loves to gain electron easily, while sodium is non-metal and it doesn't want to gain electron. On the other hand, in fourth period, bromine has more electron affinity than potassium. It is because bromine loves to accept electrons, while potassium doesn't want to accept electron. Therefore, we say that electron affinity increases from left to right across the period. Finally, we will learn trends of electron affinity down the group. Remember that electron affinity decreases down the group or becomes less negative as you move from top to the bottom. Down the group, size of atoms increases, due to which the attraction between nucleus and incoming electron is weaker. For example, in group 7, chlorine has more negative electron affinity than iodine. It is because chlorine has smaller size and it can easily attract upcoming electron, while bromine has larger size and it cannot easily attract upcoming electrons. Therefore, we say that down the group, electron affinity decreases and across the period, electron affinity increases. Hence, noted down these important trends of periodic table.